Okay, so in the last couple of videos, I was talking about a few things, and I know some of those complexes can be pretty heavy duty. You got to remember, I've been working on these math problems. The Rhodes, Fermats, Beals, Riemanns, Nova Strokers, Hunter's Prize, and a menagerie of other STEM problems, which can range. I just to cover it up and make life a little simpler, because I've done extra, and there's a few other math problem sites that I use. $10 million. Bang. So, I never travel too far from home with them. I always keep the STEM problems from their main website right on my page, and I always keep the Millennium problems right on my page, and a few different sites that go with them, especially Nova Strokers. That's a pretty complicated one, for as easy as what it is. But firstly, you got to remember, when I first started this stuff, quantum aspects really wasn't a big thing. 2012, 2013, they weren't really quite so big into the field. I mean, they might have been working on them, that stuff might have existed, but it certainly hadn't made its way to the mainstream aspect, certainly of what we understand them today. So you gotta understand, when I was working on Swag Book and those other examples, my other 256-page model, I was looking at those examples. And you'll even notice today that the questions themselves, from when I originally used to read them, they had the problems with them. Those websites that I was using, they've since changed those websites. They've taken the equations down. They've reworded a lot of the examples to make you do a certain thing that away from the original question. Because at those time, I've had a lot of this stuff done since like 2013. Well, for what I usually did, I actually used Heinrich's works, a few of them. His Heinrich's summation, Heinrich's last theorem, and a few others of his concepts in a given form, which is really algebraic in its base, to apply against what Heinrich was talking about. Now again, you get all these complicated equations and bases, but if you understand it through quantum gravity, not necessarily north, but the aspect of series of events Newtonianly on the system, A's and B's, in this fundamental design like that, are the same air turbulence equation. A lot about how I said this is an air turbulence problem, or an NP problem. How we understand this as an NP problem, not necessarily college students as they describe it in that example, but let's change it. Let's take it an A-B sequence, BA. College students, universal field theories. Things like Ohm's law, things like, this is circuitry designed to how we position at A, B, C, Z. That's an air turbulence equation equally. Not necessarily an air turbulence equation, but more importantly to what that equation talks about is smoothness. Quantum gravity is, we have trouble understanding the smoothness of it. And the existence of these is really being particles, and how we understand them. Those frames really define a lot of gravity, a lot of north, a lot of calculations that have to be functioned into this example. Those air molecules, or water molecules, or hydraulic pressure sequences, when you understand them through this common sense base, it makes the mechanics go just a little bit more simply. You're going to still need those examples, but in terms of what the real equation, when I remember it positioned out to be, I had it all written out and everything all really nice. That equation base, if you go to process it like general relativity, this equation, that firstly, what you have to know, you got a little E right there. Alright, when you see that in an equation, it can mean a bunch of different things. It can mean time, it can mean in the given environment, which means necessarily the universe, because you'll see it in Planck spectrum, sometimes you'll see it in our Planck equation, sometimes you'll see it in all kinds of different stuff, and it'll mean different things at different times, just like particles. Sometimes you put them in a different field or a different event, and the quantum relationship between those things can make different results. Quantum gravity. There's like suns and how they're all positioned in a given solar system, how water acts on a given planet, why it freezes, why we as a ruler have defined these functions to be calculable here, but why physics still works in a different place, but it'll work to different numbers, different gravities. Well, I need to understand those calculations to better predict. Well, it does apply to physics. The laws of motion, the laws of thermodynamics, they still apply. You don't really ever see equations in thermodynamics or equations in the laws of motion. It's the fundamental physics that A equation, A to B, functioned in this sequence. A lot of stacking dimension theory, specifically 3. At least. We'll get down into subparts and all that stuff. I talk about rabbit hunters and kind of lying to the system and a lot of people to this. It's a lying statement. You got to be leading this pride. It might relate to a very important calculation or a way of thinking about a thing, but it might be a unitasker, as if in this situation, not necessarily universal or unified. Unified means it'll hit everything in one move. Or the mechanical system from this first gear over here, when it cranks, this gear over here, this bagel will turn appropriately. Sorry. Anyways, so at those times I really wasn't applying quantum gravity to those kinds of functions, but in terms of reducing all the calculations to Heinrich's work, it's a great way to simplify that equation, because one of the things I heard about it was, let's find a way to describe this using simpler terms. And I'm the smart ass that I am. Well, this is a trick question. Just watch the hurricane. That's how you describe an air turbulence equation. That's how you function this out. And you're still going to have that enthrope. It's not a zero spectrum. It's not this perfect answer. It's not random. We know it's not random. But it becomes a level of compounded sequences and functions that, just to make this equation, there's a compounded functions of sequences that determine what that is. And sometimes in its given position, like the hurricane, like a topology feature, the ocean it's in, the temperature that it's in will change. That particle will change the way that thing acts, and sometimes it's very, very irrational. The square root of -1, that means nothing but applies to everything. In terms to take it away from the Big Bang, I'll subtract one thing of it and call it this. And again, that quantum gravity here is an air turbulence equation. It's in sense diversified inconsistency, negative velocities, negative accelerations, which are all great, really profound calculations to understand and very useful psychologically when you're in these events. And for me, I liked Heinrich's work. I thought it was a great way to simplify this. It's not something you will see. I had it all written out, and I know exactly where to find it on the internet, and where exactly how to process that information, how to line it up. And if you were to actually still have those air turbulence equations from Nova Strokers, I could side by side those out and I'll show you this function perfectly, and it's much simpler to apply it algebraically. A, B, B, A is a G group, is gravity, is applied of quantum gravity. General relativity is again another sequence that, if you know how to kind of pick out what functions work very well in this example, can causally very easily simplify that equation if you can understand those. Now again, that's not for everybody. I figured, if you're going to use special relativity, use this state, use this conversation. Right here is an air turbulence equation of a different form in quantum gravity. Essentially, we're taking oxygen and turning it to gold. That's a hell of a fucking transformation, and all that turbulence that has a given effect of this thesis, this lecture, which again is very complicated, and it can be a very great, useful tool. But on its own, it doesn't hold up. It doesn't stand. It's not the tool you would use to truly specify what quantum gravity is. It's not the tool alone that you could say, well, it's diversified inconsistency, and what I do in a business is an air turbulence equation at every part. The reality, we know that's what we do. this effect hitting this. It's an air molecule of a different standard. It's a given mass, nitrogen, hydrogen, oxygen. First things they don't tell you is this is an extreme case variable that's generalized. They don't tell you what altitude you're in. They don't tell you the composition of that, which alone, in accordance to the NP problem, the P versus NP problem, will simplify this very carefully. If I know those given calculations, it'll process like 1 plus 1. 2. Real simple.